Welcome, everyone. Okay, let's dive right into this explainer and unpack the highly anticipated official release of DeepSeek V4 Flash. Look, if you've been following the rapid advancements in context-heavy AI, you know that balancing sheer reasoning power with deployment efficiency, well, it's basically the holy grail right now. Today, we're doing a complete breakdown of the specific features, benchmarks, and deployment mechanics of the brand new 0731 release, which absolutely promises to redefine how we handle massive context windows.
Here is our roadmap for today. 1. Meet DeepSeek V4 Flash. 2. The benchmark breakdown. 3. Encoding and reasoning. 4. Accelerated deployment. And 5. The open source future. All right, starting things off with Section 1, Meet DeepSeek V4 Flash.
So let's start with the absolute core challenge developers are facing today, balancing speed with compute costs. It's literally the million-dollar question for anyone building context-heavy apps. You want a model that can think deeply, right? One that can handle massive amounts of context. But you definitely don't want it to take forever to generate a response, and you certainly don't want it to cost a fortune in compute. I mean, how do you scale up to 1 million tokens without your entire infrastructure just buckling under the weight? Well, the creators of DeepSeek realized standard architectures were basically hitting a wall. A totally new structural approach was required to get true efficiency at this scale.
And that brings us directly to DeepSeek V4 Flash 0731. This official release dramatically upgrades its predecessor. It entirely supersedes the preview version, bringing these substantially enhanced agentic capabilities right to the table. But here's the thing, the secret sauce, it isn't just in the training data. It's actually baked right into the physical structure of the model itself.
The magic word you need to know here is DSpark. DSpark is a speculative decoding module physically attached to the model structure. It's like having an eager assistant who rapidly scribbles down a rough draft, while a senior editor, the main model, just quickly approves or tweaks it. Because the assistant is lightning fast, and the editor only has to verify instead of writing from scratch, you get incredible, mind-blowing speed.
Moving right along to Section 2, the benchmark breakdown.
You might be wondering, how does this actually translate to real-world performance? Well, check out these Terminal Bench 2.1 scores. It is a massive leap. Even with a far smaller activated parameter count, we are seeing a jump from 61.8 in the old preview all the way up to 82.7 in this official release. That is a staggering improvement. It puts this highly efficient model right on the heels of the proprietary Opus 4.8, which scored an 85.0. It is seriously punching way above its weight class.
And this table perfectly illustrates the full picture across 9 different metrics. Just look at that deep squeeze score, jumping from a mere 7.3 in the preview to an unbelievable 54.4. That is literally night and day for software engineering tasks. We're also seeing tremendous results on internal test sets like DS Bench Full Stack, hitting 68.7. Across the board, from NL to Repo to CyberGym, these numbers prove without a doubt that DeepSeek V4 Flash 0731 is broadly competitive with the absolute strongest proprietary models out there right now.
Okay, let's hit Section 3, Encoding and Reasoning.
Let's talk about how this fits into your actual developer workflow. The mechanics of interacting with this model got a major overhaul. Actually, scratch the old way of doing things. They completely ditched the traditional Jinja format chat template. Instead, you're going to use a dedicated Python encoding folder provided in the release. The flow is so cleanly designed. You start with your raw OpenAI-compatible messages. Next, you pass them through a new encode_messages Python function. That function perfectly formats everything into an input string, which flows straight into the tokenizer. It gives you explicit programmatic control over the prompt structure.
And within that new encoding process, you also gain explicit control over the model's internal thinking. This is huge. You now have 3 specific levels to control exactly how much deliberation the model spends before answering: low, high, and max. You pass this directly into the encoding function, so you can dial up the compute for those really complex coding tasks or just dial it back for simple queries to save time. You're in total control.
Now, a quick pro tip. If you're pushing those reasoning capabilities to high or max, the model is going to generate a lot of internal thought processes before it spits out the final answer. Because of that, it is highly recommended to set your maximum output token length to a frankly ridiculous 384,000 tokens. Yeah, you heard that right. That ensures the model has all the breathing room it needs to think deeply without awkwardly cutting off mid-thought.
Section 4, Accelerated Deployment.
So knowing how to prompt it is great, but getting this beast running efficiently on your own hardware, that's where things get really fun. Depending on your backend, the configuration is beautifully streamlined thanks to that attached DSpark module. If you're using VLLM, it's super simple. Just add a speculative config flag and set the method to DSpark. Prefer SGLang? Set the speculative algorithm to DSpark. But here's the most elegant part for SGLang users. You do not set a separate draft model path. Because of the architecture we discussed earlier, both the target and the draft weights come from the exact same checkpoint. It is one single, unified deployment.
If you're spinning up the interactive chat demos from the inference folder, or just running it locally for code agent tasks, don't guess at the hyperparameters. These are the exact sampling parameters you'll want to lock in. Set your temperature to 1.0. Now, if you're running agentic scenarios, the ones that scored so highly on the benchmarks using the minimal mode of the DeepSeek harness, set your top P to 0.95. For literally all other general tasks, just leave top P at 1.0. Easy as that.
And finally, Section 5, the open source future. Zooming out to look at the broader AI ecosystem, this 0731 release is just massive. Despite offering benchmark performance that rivals the most expensive lockdown proprietary models out there, this incredible architecture and all of its weights are freely available to everyone. And we're not just talking about an open weights release with a bunch of heavy commercial restrictions, no way. It is licensed under the highly permissive MIT license. This gives us developers virtually unparalleled freedom to innovate, integrate, and build real commercial applications using top-tier agentic AI. Which brings us right to the title of their foundational paper, DeepSeek V4, Towards Highly Efficient Million-Token Context Intelligence. They didn't just build a smart model here. They've solved the structural bottleneck of processing massive context windows rapidly. With DSpark speculative decoding, tunable reasoning efforts, and incredibly permissive licensing, it leaves us with one final, very exciting question. How are you going to utilize this new era of highly efficient million-token intelligence in your own projects? Thanks so much for joining me for this explainer, and happy building.